Gentlemen, it's my great honor to be here to share our recent research. And my name is Yuyang. I'm from Zhejiang University. My presentation today is a highly sensitive superoxide anion biosensor based on PEDOT, PSS, and the sodium alginate composite conductive hydrogel. Reactive oxygen species, commonly referred as to ROS, plays a crucial role in human physiological processes. These species are generated from cells during incomplete oxidation in the respiratory tree. They are balanced by the body antioxidant defense system, including enzymes like SOD. ROS serve as key regulators in cell signaling pathways, including cell growth, division, and programmed cell death. However, under pathological conditions, ROS levels can exceed the body's natural antioxidant defenses, leading to severe diseases like diabetes and some neurodegenerative conditions. Therefore, monitoring ROS levels holds great potential for us to get more early disease diagnosis and proactive medical interventions. Several key ROS involved in human health are superoxide anion, hydrogen peroxide, and hydroxyl. While hydrogen peroxide has been extensively studied in ROS detection, we recognize that there's a need for a more comprehensive understanding of ROS dynamics. However, the development of detection methods for superoxide anion is hindered by its short half-life and low concentration in biological systems. To address these challenges, researchers have explored various detection methods with a primary focus on electrochemistry and fluorescence imaging-based methods. Among these methods, electrochemical approaches have gained prominence because of their ability to provide precise quantification and a rapid response. Nevertheless, it's worth noting that there are two main limitations in electrochemical methods for superoxide anion detection. The first one, many of these methods need complex modification. And the second one, many of these methods fail to detect the target at low concentrations. Here we propose an electrochemical biosensor based on a composite conductive PEDOT, PSS, and sodium alginate hydrogel. This hydrogel enables rapid and sensitive detection of the superoxide anion. Importantly, this composite hydrogel has good mechanical and conductive properties and needs only two steps to fabricate. Firstly, copper is electroplated onto the gold electrode. And secondly, electrolyze the copper into ion form, and copper ions will help PEDOT, PSS, and SA to depolymerize. And sequentially, these depolymerized PEDOT, PSS, and the sodium alginate will reassemble together to form a uniform hydrogel. The morphology of the PEDOT, PSS, and sodium alginate composite hydrogel was characterized by scanning electron microscopy. It demonstrated that each component and their composite hydrogel has loose and porous structures. However, the composite hydrogel displays a more uniform and compact size, forming a well-organized hydrogel network. These results, along with the unshowed FTIR analysis, confirm a successful compounding between PEDOT, PSS, and sodium alginate. This composite hydrogel has good conductivity to facilitate the superoxide anion detection, we modify SOD onto the hydrogel electrode. Cyclic voltammetry shows a pair of redox peaks only on the electrode that is modified with SOD and the composite hydrogel. This reveals that there is a direct electrochemical behavior happened on the electrode. Further, we add standard solutions into the detection system, and the corona ampermetry show that each addition can elicit a similar increase in the current intensity. And further analysis demonstrates a linear relationship between them, and the correlation coefficient is up to 0.9997. This illustrates the credibility of our finding. Notably, our sensor exhibited good performance at low concentrations, and our detection limit is about 7 nanomolars per liter, and this is close to the physiological levels of the superoxide anion. Our biosensor has also exhibited a good anti-interference performance. Various reactive substances commonly found in body fluids, including ascorbic acid, uric acid, glucose, hydrogen peroxide, urea, and dopamine, were also introduced into the detection system. And we can see in the figure that they don't generate a significant signal compared to the superoxide anions. Moreover, we, on the right side, you can see our biosensors has high consistency among a bunch of the biosensors we fabricated. The relative standard deviation is less than 10%, and these electrodes maintain approximately 85% of their detection performance after 1 week, being stored for 1 week after fabrication. And this shows that they also have good stability. After that, we test our biosensor on diabetes rat models with non-healing wounds. The non-healing wounds in diabetes patients have been a worldwide medical concern. By attaching the composite hydrogel electrodes to these wounds, we monitor change in ROS levels over time. As the wound healed, we can see that the ROS is significantly decreased, and our result is consistent with the results we get from the commercial ROS kit. In conclusion, we propose a highly sensitive and selective electrochemical biosensor based on PEDOT, PSS, and sodium alginate composite conductive hydrogels. And we particularly focus on superoxide anion at low concentrations. Besides the simple two-step fabrication process and the good conductivity, our hydrogel has good mechanical properties that it can be flexibly modulated by adjusting the content of each component in this composite hydrogel. We can regulate the modulus, Young's modulus, to match the different body tissues and organs. So, for example, by tailoring the Young's modulus of the composite hydrogel to that of the human skin epidermis, it is anticipated to enable continuous non-in-cell monitoring of biochemical signals, including ROS. And that's all for my work today. And I would like to acknowledge the support received from the following foundations and express my gratitude to Professor Liang Bo for his guidance and financial support. Professor Liang Bo's lab is dedicated to advancing biosensoring technology and detection devices. Our team has published several research on PEDOT PSS hydrogel previously. And thank you for your kind attention. And I'm now open to your questions.